Okay, are there any questions? There was a question about this business of Y drive. What is it? Where is it? And things like that. I will check with the system administrator. I was under the impression that even if you go there on the computers there, you can actually see the Y drive. But I was told that maybe it's not there. Maybe it's not visible yet. I don't know. So I'll let you know. Definitely before the test, for sure. Now, if there are no questions, so what I would like to do today is this problem you have seen. This problem you have seen, and I did it, I think it was on Thursday last week. What I did with many planes of symmetry. Okay. So what I like to do is to resolve this problem twice. Both of them involve plane of symmetry, but one of them as a single part. Okay, as a single part. And then once we do it, we come back and solve it as an assembly. Okay. The reason I want to do it then as an assembly also is that in the lab, just last Friday, somebody says, "I'll solve this thing as an assembly." I said, "Oh, can you show it to me?" So he shows it to me, and basically it is that product file. Remember the product file that by default you get on the screen, and I always close it. So he inserted a part in that product file and just solved it as a single part. Yes, this single part, which has the sheet in it, which has the cylinder in it, which has all these rods in it, was a single part inside an assembly. That's not what I mean by solving it as an assembly, okay? Solving it as an assembly means that that assembly has 4 different parts: the cylinder, the sheet, and left bar, right bar, or maybe you can do it with 3 if you want, with the 2 bars as the third part. Okay, 2 bars in the third. Not as in doing it as a single part and just putting it in an assembly in a product, because that's how it started. Get you started. Okay. All right. Any questions, ambiguity about this? Okay. Now, in this problem, you do have a plane of symmetry. Remember, the tops are clamped, the bottom is clamped, the bottom of that cylinder is clamped, and the surface is pressurized. We don't really question. We don't question whether. Let me put it this way: this cylinder was inserted inside of a hole. That's how I did it, right? I created that sheet, and there was a hole in the middle, as if this cylinder was we took it and put it in there. Okay? But somebody might say, wait a minute, I look at this, maybe you actually had a sheet without a hole. You bought half a cylinder, put it on the top, somehow glued it to the surface of the sheet. Got another half a cylinder from the bottom, you glued it to the sheet. Wouldn't that look the same? The answer is yes, it does. And it doesn't matter how you solve it for us, for me, for this course. Doesn't matter. Okay? For the static analysis, it doesn't matter in all likelihood. But for dynamic, these things are critical. You cannot, just randomly go ahead and do things. And in order for me to ask you to do a dynamic problem, we have done very limited dynamic here. Very limited, just natural frequency calculation. I have to give you more information. Pretty much everything that we do here is static. Everything that we have done is static. Okay. So when I look at this, I do it the way I told you, that I'm going to make a hole inside of that sheet and then put the cylinder in it and do the rest. Okay. Now, you also have the option of making everything exactly like it is, and then try to cut it with the saw that you see in the assembly design. That's assembly. Never mind. Never mind. We're going to talk about that later on. You have a choice of making these things exactly like it is and then start cutting it, but just be aware of the fact that the split that you use for cutting that cylinder is in part design, and the split that you use for cutting that sheet is in generative shape design. You cannot cut a surface with the one or split the surface with the saw that you see in part design, or the other way around. Okay? So that's up to you. What I'm going to do is I'm going to make only half the model. Okay? Single part, half the model. I'm assuming there are no questions. If there are, let me know, please. So I'll go ahead and part. Okay. I'll just draw half of that arc. Okay, half of that arc because I'm going to pad half of the cylinder. Okay, so let's do the part. Let's do the part first, the cylinder first. So I'm going to go to part design. On that face, I will sketch. Not worry about dimensions, but just put something for one of them so that I have a rough idea of what sizes are. Okay, so this is my half a cylinder, half a circle. Let me just put a dimension here so that, yeah, 2.5, okay. 2.5 inches, radius 2.5 inches. All right, now I have to close this, because if you have an open profile like that, or if you have this profile and another line next to it and a point over there on the same sketcher, you won't be able to pad. Okay, if you have situations like that, you may want to turn those things that you do for some reason you had it there to construction entities. For example, if you made a point here, and then on this screen you made a point, you can do that here, right here, right. See, point, line, and it's just hanging there. Then you won't be able to pad this, okay, because it's an open profile. You have to turn those into construction entities. Open profile can be padded by given a thickness. So basically it becomes a sheet metal type thing with a given thickness. If it's open, you can pad it, but not as a regular pad as specified the thickness also. But I'll close it. That's not what I have. All right, exit. Yeah, let's pad it by, I don't know, maybe 10 inches, 5 inches in each direction. So let's see now. Let's see how it looks like. When I say thicken, is this. Open profile, you can thicken it, but not this. 5, mirror extend. Yeah, okay. So there we are. Then I'm going to create that sheet. Okay, everything is in the same part. So on that same plane, I will sketch. Well, I have a choice of doing half of the sheet, and that's what I'm going to do, or the whole sheet, and then use a split later on to cut it, to split it. Okay. So something like this. First of all, let me project this piece on that sketch. So project this piece. Hang in there. Project that piece on that sketch because I want to make the rest of it. So let's see now. Profile. We start here. Go up. Like that. Like this. Wrap it up. And if necessary, clean it up. Okay. If this is not closed, and it is closed, I'm pretty sure it's closed. You know, but if inadvertently I left a gap between two things, you won't be able to put a surface on it. Okay. But I'm pretty sure this is okay. If not, we come back and close it, clean it up. So exit, and I want to put a surface through this closed path. And that you have, obviously, as soon as you say surface, you have to be in generative shape design and look for fill. There's FILL. Hopefully this is closed. And there we are. And if I hide this, obviously, there it is. So undo that. Do not forget to save. On Friday, it happened. A guy came to me and said, that group came late anyways. Came to me and said, I didn't save anything. and his computer crashed. Happens. I think he learned his lesson, but anyway, so file, save management, save as, desktop, new folder, 830, part. How about that? Parts, okay? A single part, that's what I mean. Say okay, and okay. Then we're going to do the line. So create a line on this plane in the direction, point and direction, okay? Point and direction. In the direction Z, let's go by, I don't know, maybe 5 inches, see how it looks like. I think this, we have to change it to 0 also. Let me go up. Oh, there we are. There. Now, once again, it happened on Friday. Somebody said, I can't mesh this. I can't mesh this bar. And I asked them, did you sketch or did you draw a line? Obviously, I drew a line here, but I think she said I sketched it. I said, what do you have to do when you sketch things? She had no idea that it had to be joined. When I told her, she said, really? So, yeah, really. Okay, there we are. And then we're going to save this. But let's put material, it's made of the same material. So aluminum, steel, aluminum, okay. And then save everything. We are good. Now, right. So now we're going to go to generative shape design. CATIA immediately measures that solid for you. And then I have to do the rest. Okay, so you go to shell mesh. We mesh this. I'll make it smaller, 0.5. Okay, oh, it's parabolic, that's fine. That takes care of this. You put a thickness on it. It says 0.1, so I'll take 0.1. Then we're going to mesh this guy. So beam element. And notice that we can mesh it. If this was a sketch, you have to join before doing this. You won't be able to mesh it. 0.5, okay, that's about maybe 6, 7 elements through the length, no problem. And then we specify the cross section. So let's do it. I think it was a rectangle there. So rectangle, because without, if it's anything but a tube or a circle, you cannot close this. You cannot say okay. But rectangle, if it's a circle, you can, but not. And how about making it 0.1, 0.1? It just happens to be like that. Obviously, I'm going to give you the information if needed. And notice that I can't close it without using a orientation point. So the orientation point cannot be on the curve itself or on the continuation of it. And the reason is that you drop a perpendicular from the point to that line. If the point is on the line, perpendicular to the line doesn't make sense when the point is on the line. So I'm going to select this one. Now, if I cannot select that corner, that's because this bugger is blocking my view, the sketch. So I'm going to hide the sketch. And now, oh, let me cancel that. Let's try it again. Okay, rectangle, not tubular, rectangle, 0.1, 0.1, 0.1. Say okay. And I try to pick this, it won't take it. Then I blame that on the sketch, but maybe I have to put the orientation, select the orientation geometry, and then try to pick it. Still, that was the problem. Block this. And now I can select this corner point. Okay. Now, oh yeah, the whole support is this. We obviously, it says, what are you trying to put properties on that line? I forgot to take it. Now, if you zoom in, you see that actually there's a very tiny little rectangle there, oriented properly. Okay. If I had made it 1-on-1, you could see it, but I made it 0.1, so you can't even see it when you're way out there. Okay, good. So first thing we're going to do is to save our analysis. File, save management, save as, in that same folder. Yeah, that's good. All right. Now, the top of this is clamped. Make sure you don't, if you happen to have a point up there because of the way you drew that line, just don't take the point and think that you have put a clamp on the point and it's going to work. It doesn't. Points, lines, and things like that are not finite element entities. It has to be a vertex, okay? But I don't have it because I didn't create it like that. I said point and direction. The point, direction, there's nothing up there. But somebody could have done point to point, created 2 points, and then connected them with a line. Then make sure when you do that, you hide that point up there, because if you put it on the point, you'll take it. But you won't see it later on when you run it. Okay, we also have this bottom. In this particular problem, I can lump them in the same one. You don't have to. You can do a different clamp. But there's 2 things. The top is clamped. You see that? And the bottom is clamped. Okay, good. Now let's pressurize this. I'll put some pressure. Make sure that the direction is correct. This is correct. Pushing down. Okay, that's why I needed this minus sign here. Okay. Good. And now we create connections between these guys. So you have a choice. You can do this surface to that surface as a connection and make it fasten. You can make the edge of this sheet and that surface, make it connection and make it fasten. Okay, that's a possibility. It's up to you. Okay, both are acceptable. So let me do this surface to that surface. It's easier because then otherwise I have to. There are some differences. There's no doubt about it. But both, as long as the mesh is okay and everything else is done, will give you very close results. Okay. So let's see now. Connection between this face for second component, that thing, face, and this is going to be fastened. I think when I did it for you last Thursday, I did edge to surface. All right, so where is the fasten stuff? This is face-to-face connection. Fasten is over here, and I can select it from there. And then you have to do point to point, okay, and make it rigid. Now, somebody asked me a question. What if I do this edge to that face and make it fasten? I think it will work. If you do it like that, I have no problem either. Okay, but don't make this with that rigid. Okay, if you're doing it rigid, it must be these 2 points. The reason is that if you make this connection with that, make it rigid, neither one of these will actually change shape. Neither the line will stretch, nor the sheet will stretch. Rigid means rigid. Now we can do it to point because it doesn't matter, point and point, rigid, okay, fine, no problem. But when you do a line to surface and make it rigid, this is going to be rigid, this is going to be rigid, means that these stay put. They don't do anything. And these are things you can try. Try it before you take my word. Let me do point to point connection. We hide this between this point and let me bring this thing there and hide that guy. And I'm trying to take this point. If I take cannot take it. That's because I'm trying to make that connection and put a dot there. So hide it, just hide it. There. And this is going to be rigid. Now, where's that connection? That last one? Good. Run it. Run it. What do I have to do? Yeah, symmetry restraints. Symmetry restraints. Okay, so let's do on this guy, surface slider. And if you don't like surface slider, all that does is that perpendicular to that direction, there's no displacement. So that direction is X in my case. So you say no displacement in X. You can do that. It's the same thing. And the shell. These two pieces are critical for full mark. Okay, so we do surface defined restraint, uncheck all of these. That's a good strategy to uncheck them. This edge and that edge, these are on the plane of symmetry, YZ plane of symmetry. As soon as I say YZ plane of symmetry, no X. No X. And once you get the translation, these are exactly the opposite. Notice that that circle, half a circle, is not on the plane of symmetry, obviously. Okay? It's just these two edges that are on the plane of symmetry. And we say, okay, let's save everything and run it. Now, it happened to quite a few people on Friday, maybe 20, something like that, that they did everything right. Everything was right. But when they tried to run it, it did not. It gave this weird message. I don't know what it says. You don't know what these things, most of these things say. Which, in some cases, we tracked it down. Okay, we sat there 5 minutes with the guy and sorted out what the issue was. There can be many different things by going to the tree one by one, checking it. But then we reached the point that everything was right, but it would not run. Now, he didn't tell me, of course, what he had done before that. You know, you go and play with your phone and things like that, and after a while you press everything, nothing works. So what do? So you reset it. Usually it goes back. Unfortunately, at that point, you have no recourse. You have to scrap that analysis because you can't figure out what's wrong. I can't figure out what's wrong. You did everything right, but it won't run. And that is the deal. I told them that is the difference between 35% or the full percent on whether it runs or not. Right? So if you decided to manage your time so that you don't have to do things like this in anticipation of something being scrapped, well, that's your problem. Okay, it's not Katia's problem, it's not my problem, because we don't know what this guy did. Delete this, put that, and the whole whack of it. Eventually, Katia gets confused. I mean, software gets confused. That's exactly what you do with cell phone. Reset it. Your, I don't know, cable, reset it, and everything's going to come back. But you have to allow yourself, if you do crazy things like that, you have to allow yourself time to go back and fix it. Fix it means scrap it. Okay? Usually it happens in the case of analysis. Okay? It should happen only here. Did I run it? I don't think I ran it. How do I know whether I ran it or not, by the way? What do you say? Yes? Yeah, these are all blank. You're right. Okay? Okay, so let's run it. This is the common message that we get. I don't know. Maybe you guys don't get it, but I do. All right, it did run. Let's look at the deformation. First thing we do, we look at the deformation to see whether this whole thing makes sense or not. Yeah, it does make sense, right? Let me change the rendering here to third one. You can see your elements, okay? There's all these crazy things that you see there. These are These are internal elements for that fasten connection or contact connection that you created, okay? And because I made surface to surface, remember I made surface to surface, fasten? I mean, if somebody does edge to surface, it's going to look different. Because here, I don't know internally how they wrote the code, these internal elements for me, even though it may be exactly the same mesh, we have done exactly the same thing, the difference is in that connection, edge to surface or surface to surface. The shape of those things will look different, okay? Now, if we don't want to see these, and really we shouldn't look at it because these are totally useless for us. We can say, just show me don't show me everything. Just show me, for example, part one, the mesh, shell mesh, and the beam mesh, which is, where is it? Right here. Don't show me all that garbage. That garbage is important, but not for us. Internally, it uses the stuff, those elements. And I'm not going to do the rest of it. Deflection, you can see, and one meter stress, etc. Okay, any questions here? All right, so let me save this because I want to minimize the amount of work that I'm going to be doing, okay? So what do I mean by that? What I'm going to do is I'm going to close this, and I'm going to close that. So I have a folder here called 830 right there. This is where I put my stuff in there. Oh, God. Okay, I have to create the parts separately now. Unfortunately, I thought for some reason, yeah, don't worry about what I said. Let's do another one. We have no other choice. Okay, so let's go there. Product, okay. Immediately save it. File, say management. Save as. Up, desktop, where is that? Desktop, new folder. 830. Assembly. There, we say okay, and we say okay, there. So once again, I can make half of it or the whole thing. I'll make half of it. So insert, new part in there, and I'm going to call this cylinder, properties, cylinder. Did I do that? Cylinder. Maybe I have to go down. Oh, there, part, this is the one, cylinder. Okay, let's make it. Double click on that same plane. I will sketch the same half a circle. Let me give it, I'm not going to even bother about dimensions. Maybe I should. 2.5 and close it up. Align. Lousy. And the reason is that this point, I wanted it to be on that line. I was sloppy in doing it, so let me clear it up. This point, control that axis. Coincident? Okay. All right, there's the normal view. You know, little things like that can make or break your problem. Because if you cannot fix this is the first step. If you cannot do something like that, it is a problem. You may be better off getting rid of the sketch and doing another one. All right, exit. We have to mean part design, so we go to part design, and we're going to pad it 5 up, 5 down. 5 up, mirror extent, 5 down. Good. We're done here. So we go to product, insert the second part, which is going to be that sheet. So insert, new part, I'm going to call this thing the plate. Right click properties, plate. I'll do this one, plate. And make it exactly the same strategy. First you go to the plate, and on that same plane, you sketch and project that same thing. Or if you don't like project, go draw it. Okay, and complete the rest of this, just like we did before. I may have to clean these up, I don't know. I don't like this, but anyway, we'll see. It could be that because I'm not looking at it from the exact normal direction. Yeah. This one, we make it horizontal. Still there's a, yeah, that looks good. We'll see. So exit. We go to the generative shape design. Fill this, F-I-L-L. That looks okay. And then go there, product, insert our third part. Insert, new part in there. And I'll call it support or cable. Right click properties. I'll call it support. How about that? Okay, let's make it. So I go to the support. I have to draw a line. There we are. Point and direction. The point is right here. Direction is Z. And this is 0. Let's put a 5 here. Maybe 10. Okay, at the end of the day, you have to have something like this. Whether it's in a single part or an assembly. Well, I did a single part for you. You go up there and you put properties of steel on it. Properties, steel on that product. Immediately save it. We already saved our product. All we have to do is to click on the floppy and it saves the stuff that we did since then. That's pretty much it. So now we're going to go to generative structure analysis. Okay, so it's already meshed this. So let's do a shell mesh for that surface. Make it smaller. Okay, put a thickness on it. Let's mesh the beam. And rectangular dimension is the same because I didn't change it since then. I'm going to select support. And for the orientation point, I will select this. If it doesn't let me pick it, it's because of the sketch. Hide it. And then select that. Okay. That's pretty much it. Connections. This time I'll do edge to edge. How about that? I'll do edge to edge. So you don't have to. Not edge to edge. Edge to surface. Okay. So this is the first component. Second component, I'm going to hide that. I'm going to select this. And I get that. And this is going to be fastened. Means purely perfectly bonded, perfectly or welded, stuff like that. That's really what I mean by fasten. So fasten connection on this connection that I created, which is right here, right there. You say okay. And for this guy, I have to do point-to-point connection. You know what? Let me try the line, and the surface, and make it fasten. Don't make it rigid, because rigid means they're not going to change. Let's see if it works. So the line, second component, that surface, and then fasten. Now what? Must be a fastener somewhere. Did it do it? It didn't put a fastener sign on. I don't honestly like it. We're going to find out. We may have to come back and do it point-to-point rigid. We'll see. So let's do the restraints. So surface slider here. User-defined restraint. And because I did the same coordinate system, everything, so all I have to do is to select this edge and that edge, because everything here is correct. It was the same setup that I had before. And for clamp, the bottom of this is clamp. And I'll make this top and put a pressure there. No, the direction is correct. Okay, I'm going to run it, but I'm not very, very optimistic, because I would have thought that it works, but if it did, then where is that second fastener sign? I don't see it, so I don't like it. Let's save the analysis first. File, save management, analysis. Don't do any. Don't give us all these temporary files. Where are they? Oh, I haven't run it there. There are no temporary files yet. Okay. These are the part files, the 3 part files, and product and the analysis. So save as. Once you run it, there's going to be 2 extra files which are temporary files. We don't want it. Don't give it to us. Don't upload it. You don't have to. Folder 830 assembly. Good. Okay, let's run it. We'll find out whether this fasten thingy works. But I'm surprised that I don't see a fastener sign there. Maybe they're sitting on top of each other. I don't know. Yeah, it looks like it works. I could have done point-to-point, rigid, line to surface, fasten. Different. Any one of these would be acceptable for me. For real life, then you have to be very careful. In other words, what is going on? One of the things that you cannot do it like this is that this was a cable. If this was a cable, you cannot prevent that cable from bending anymore. Because when you do it point-to-point rigid, then you can go and release the degrees of freedom. Okay? Release the degrees of, so be careful. If I said these are cables, this is not going to do it. You have to do it point-to-point, rigid, and release the corresponding rotational degrees of freedom. Any questions here? Yes. Yes. Okay, let me show you that. That's wait. I think the most significant contribution that I've done to the University of Windsor engineering, mechanical engineering community is to show them that. And I'm not very happy to say it, very proud to say it. But this is a common question that comes up. So let me go ahead there. At least I taught you something. So let's go to the product. And one of these parts, so it doesn't matter. So let me go to the cylinder. I'm going to erase that portion, by the way, before I post it. So on a convenient plane, say on this vertical plane, I want to sketch something. Okay. So you want to draw a line, a curve, a line, another curve, maybe, etc. So first of all, the grid is here. I deactivated the grid. You can see the grid. Oh, there it is. Just so that you know that I'm in the sketcher. Okay. So you go to the profile, you go to a place, and then you want to turn this thing into a curve. Okay. So you click on it. Don't move. Just click on it and drag it a little, the mouse a little bit. Wait. Okay, let me try it. Try it again. Drag it a little bit. Don't let it go. You want to get a line? Click, line. You want to make it a curve? Click. Don't let it go. Drag it a little bit. It turns into this. By the way, whether it becomes tangent or not, you can control it with these guys. This guy looks like a hockey stick. See that? What is this? Right there. Looks like a hockey stick. It goes line to line to line. If you get this one, the curve that you draw is going to be tangent to that line that you drew. Or if you want to bump like this, then it's the other one. Here, let me. Now that you made me do it, so let's try it. So, okay, click. If you click on this guy, which is already selected by default, look, selected, it turns into a line. If you click and you want to turn into a circle, do what I just told you, or come and select one of these guys. For example, this, you see that? A circle with a line. You see that? I didn't drag it. Those two icons do the job. Line to line, line to a circle with a tangency, and line to a circle with no tangency. Give